You are welcome to Math Demystified.
Next is difference of two squares, and it is defined as the difference of the squares of two quantities is equal to the product of their sum and their difference. Let's pick this statement and break it down. The difference of the squares of two quantities. So let's pick the quantities. Let's say the quantities are A and B. So if A and B are my quantities, and they say the difference of the squares of the two quantities, it means that difference, difference is this. So the first quantity, this square, and this square. So the difference of the squares of these two quantities is equality sign equal to the product of their sum. So the sum of the two quantities is A plus B, and their difference, the difference is A minus B, and this is their product. So this is the definition for difference of two squares. We all know that if you pick this and we open this bracket, we'll get this back. Let's check that. Let's check it. So if I have A plus B and I have A minus B, let's try and open the bracket. If this multiplies this, I will get A squared, and this A multiplying this again, I'll get minus AB. Let this multiply this, I will get plus AB. BA is same thing as AB, and let this multiply this, you're going to have minus B squared. You see, this will cancel this, and that will leave you with A squared minus B squared. This is equal to this. You can see. So, and you know that when you learn rules, you learn from the left hand side to the right hand side, and you should also be able to write the rule from the right hand side to the left hand side. So the difference of the squares of two quantities is equal to the product of their sum and their difference. Now, still on the difference of two squares, let's practicalize this. If you have a square, so we have this square, and this is A, this is A, everything here is A, and this is A. If I have another square here, let's cut out a square from here, and let me draw a diagonal that will run like this. Okay, so let's call this dimension here B. Let's call this B, call this B, and call this B. That will make this not to be A any longer. From here to here is A. So if this is B, this part will be A minus B. This part, similar to this one too, from here to here is A. So this part is B. That makes this one to be A minus B. Okay, now if I cut out this part, this part will look like the shaded portion. This part becomes the shaded portion. So if they are together like this, it's a single square. If I remove this square from it, then it becomes difference of two squares. Can you see that? There is a square here that this square can fit into. So if I remove this square from this, what I'm going to have will be difference of two squares, which is the shaded portion. And you know that anytime you are asked to find the area of any shaded portion, what you always do is the area of the whole shape, then minus the area of the empty part. Let me remind you what I'm talking about. If you have this shape as a circle, I have another circle inside, and this part is shaded. And from here is capital R, this is single R, I mean small r. And you're asked to find the area of the shaded portion. You say area of the shaded portion is pi capital R square minus pi small r square. Why is that? The pi capital R square is the area of the bigger circle. The pi small r square is the area of the empty parts, the shaded portion. That's exactly what I'm going to do right here. So let's try and do it. Let's try and do it. So if we do it, we're going to have area of the whole big shape. You know, this is A, and A. Area of the big shape is A square. Okay? So now, area of this part that is empty is minus B squared. And that's what's going to give us what we have. So this one is called difference of two squares. So when I do that and I pull this one out of this, what am I going to have next? Please think about it. Okay, welcome back. Now, after thinking about it, let's see what we're going to do, how we're going to do it. Now, you see that what I've done here is I pick the area of the bigger shape minus the area of the empty part. That is this. And that is the same thing as what we wrote when we started. What is it going to be? Let's come back to this shape. So after removing this part, what I will have that part left will be like a trapezium. You know, it will look like this. What I'm going to have left look like this. This part here I called A, and this here is coming over there. You know. Then this part I called B. Okay, I called B and coming over here. So I've drawn this part, and this is it. Here I called it A minus B. Call it A minus B. Now I want to bring this part and arrange it so it can align, you know, with this one. So if I bring this one, turn it over, bring this part and bring it this way. So this part that you see, this part that is B, this B part, if I bring this, it's going to be small like this here, this B part. Okay, now this is A minus B, and I want the A minus B to also be here. So when I move this A minus B, if I turn it and the A minus B, this part is the B, A minus B will come down like this to be this part. So this A minus B, don't worry, I'll show it to you practically when I'm done, so you can understand. So this is my B. So here is also my A minus B. Okay, the part left that I've not used now is this part, and that is my A here. This will be my A. So if I do this, it will form a rectangle. And don't forget that we can find the area of this triangle. We're dealing with area all along. So for me to find the area of the triangle, this part you are seeing, this upper part and the lower part, everything here is A plus B, because this is A and this is B. So if this were to be 7 and this is 3, if I add it together, I will get 10. So this is A plus B. So the other lower part too is A plus B. So if they ask me to find the area of this, I will get length times breadth, where the length is A plus B and the breadth is A minus B. And that's, you know, was what we got when we expanded, when we factorized this the first time when we started. So you can see that now. I'll show it to you practically so that you can see. Okay, so you see that originally we had a square where we have A here and this A, everything here is A and everything here is A. Can you see? So it's a big square. And I have another square which is B, everything here is B, B all through. If I remove this B, I want to find the difference between this bigger square where we have A, and A, and I want to find, and I have another smaller one which is B. That's the dimension. So if I want to find the difference between them, that means I'm separating it. If I find the difference between them, this is what I'm going to have left. That's the shape I'm going to have. And each of these shapes is a trapezium. This one too is a trapezium. See, they are the same thing. Okay, forming trapezium. So what did I do? I decided to put this like this. Okay, and this part, I brought it here like this, and I turned it the other way. I form a rectangle. And when I do, you see that this part is A. Okay, let me look for my marker. And this part you see here is B. Let me show it to you. You see, it's B. That's our B, the B. So this is the B. So let me write the B there for you to see properly. So this is my B. So this part is A minus B. Here it is A minus B. So this is A, this one too is A. So that will make it be A plus B up here, and this one too will be A plus B here. So you have A minus B, you have A minus B. So that the area of this rectangle you now have is now A plus B into A minus B. I hope it's clearer now. Thank you. Examples on difference of two squares. Few examples on difference of two squares. Now, factorize the following. That's the first one. Now, if you look at this, this is y squared. You can write a number, square it to get 4, and that is 2 squared. So this is looking exactly like the law we just learned. So this can be written as y plus 2 and y minus 2. It's as simple as that. And let me tell you here, it does not matter the one that starts first. You can put minus there and put plus there. Don't forget we're dealing with product, and that won't matter much. Come over here and look at this. There's a number I can write as a square to get 36. There's another number I can write as a square to get 9. So I'm going to express this as 6 square, because 6 square is 36, minus, this is 3 square. So I have 3 square and a square. So it will be easier for me to write this as 6 square, bring this together. If you remember your indices, they have the same power. Because they have the same power, I can write this as 3a, put it in bracket, and square. So you can now see that this is looking exactly like the law too. So this is like my A, where the whole of this is like my B. So I end up having 6 minus 3a and 6 plus 3a. And that takes care of the problem. Let me adjust this board for you to see better. Okay, thank you. Just a minute, adjusting the board. Okay. Now let's go to the next one. So from here, I guess you'll be able to know what to do. There's a number you can square to get 25, and that is 5 square, and this m square, minus number you can square to get 16, 4 square, and this is n square. And this can be written as 5m, put in the bracket square, minus 4n in bracket square. If you write this as 5m square, you will not get the answer. Even if your answer is correct, you will be marked down because it's not right. So this is how it should be expressed. And you can now see that the whole of this is like your A, while the whole of this is like your B. So you end up having 5m plus 4n into 5m minus 4n. That's the product. And that's all. I hope it's clearer now. 2. Let's look at this number 2. We want to factorize this. And you will see there's no number you can square to get 5. And there's no number you can square to get 45. So the first thing you want to do here is to check if something is common. Good, 5 is common to the two numbers. Bring the 5 out. It's a common factor. So if you bring the 5 out, what will be left here will be a square, because when you use the 5 to divide the whole of this, you have a square left. Minus, use the 5 to divide this, you have 9. Okay? Now look at this. It's not advisable to leave your answer like this. Why? Because if you open your eyes, you will see that there's a number you can raise to power 2 to get 9. So bring the number there, and this gives you a square minus 3 square. And we have 5 into, so apply difference of two squares, a minus 3, a plus 3. Do not forget, it does not matter the one you write first. You can put the plus there or put a minus here. So this becomes the answer to that question. Let's look at this next question together. You see that this is x squared and this is 1. If you think properly, you will discover that when we're learning indices, we're taught that 1 to any power will give you 1. So if I look at this 1 and I raise it to power 2, I will still get 1 back. It means no harm is done. So I come over here, I write my x squared minus, because this is square, I would rather square this one so that they can have something similar. So this can now be expressed as x plus 1, x minus 1. It's as simple as that.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.